1/2 times 3. Number 41, which of the following vertical lines cuts trapezoid ABCD into two trapezoids with equal areas? So I have equations, 5 different equations of vertical lines, and I've put one in here. We have a vertical line, and we want to know which one would divide the trapezoid into equal areas. So if we just try, let's just try this bottom one here, x equals 6.5. So we'll put this vertical line right here at x equals 6.5. And if I look at the bases, see let me look at this one first. I have this trapezoid. This trapezoid has a base. Well, I start at x coordinate of 2, and I go to 6.5. This will be x equals 6.5. So from 2 to 6.5, that gives me a base there of 4.5. The upper base, I start at x coordinate 3 and go to 6.5. So that gives me an upper base there, a length 3.5. The other trapezoid over here, the other one, I have a lower base here. I start at 6.5 and I go to an x coordinate of 12. So let's see, 6.5 to 7 is a half plus my 5. So this would be 5.5. The upper base, I start here at x coordinate of 6.5 and go to 9. So 6.5, 7, 8, 9. So that would be 2.5. The area of a trapezoid is the formula area equals 1/2 times the height times the sum of the bases. Well, both of these trapezoids are going to have a height for both of the trapezoids. We go from a y coordinate of 1 to a y coordinate of 4. So both of them are going to have a height of 3. Then if we look at the sum of the bases, for this trapezoid, we have a base of 5.5 and 2.5. And if I add the two bases together, I get the sum of the bases is 8. And if I look at the other trapezoid and add the bases together, I have 4.5 plus 3.5. So 4.5, 5, 6, 7, 8. The sum of those bases are 8. So both of these trapezoids would be 1/2 times 3 times the sum of the bases, which is 8. So my answer is x equals 6.5, or E. Number 42, given that f of x equals x minus 1 over x, and g of x equals 1 over x, what is this composition function, f of g of 1/2? Well, this is a composition of two functions, f and g. We always start at the innermost functions here and evaluate this. So g of 1/2, first I'll just write the whole thing down again here, f of g of 1/2. I'm going to start in here and evaluate this. I'm going to plug 1/2 into the g function. So here's the g function. and I plug 1/2 in for the variable. So that would give me 1 over 1/2. 1 divided by 1/2 is the same as multiplying by 2 over 1. So 1 divided by 1/2 would be 2. If you're not sure how to do that, you can always just enter that in your calculator. 1 divided by 1/2. So now we have f of 2. Now we're going to take 2 and we're going to enter that, plug that into the f function. And here's the f function. So f of 2 now would equal, we're going to plug 2 in wherever we see an x. 2 minus 1 over 2. So this would be 2 minus 1/2. Well, if I get a common denominator, this would be, multiply the numerator and the denominator by 2. So that would be 4/2 minus 1/2 would equal 3/2. And I look at my choices, and K, I see 3/2. I could have also just taken 2 minus 1/2 and said, well, that's just 1 and 1/2. But then I noticed that that's not any of my choices. But 3/2 is the same as 1 and 1/2. The answer is K. Number 43, we're given a formula. And it tells what all the different variables stand for. But the main question starts down here. It says when A is multiplied by 2, when A in the formula is multiplied by 2, what is the effect on P? Well, looking at the formula, I see that I have an A here and here. So I think it might be easiest if I just factor out an A, which is what I did here. I factor out the A. So I get P equals A times this quantity divided by 12y. Well, then if I think about the question, it says when A is multiplied by 2, what is the effect on P? So if I would just take A and I'd multiply this quantity by 2, well, the effect on P, in order to keep these two sides equal, there's an equal sign, so I would need to multiply P by 2. So multiplying A by 2 is the same thing here. To keep those equal is multiplying P by 2. And that would be D. P is multiplied by 2. Number 44, the points E, which is at 6, 4, and F, which is at 14, 12, lie in the standard XY coordinate plane shown below. Point D lies on EF between E and F, so somewhere between the E and F, such that the length of EF, so this whole length from here to here, is 4 times the length of DE. What are the coordinates of D? Well, I'm going to put in a triangle here. I can see I go from x coordinate 6 to x coordinate 14, so that would be a distance, a length of 8. I go from y coordinate 4 to y coordinate 12, which would be a distance of 8. Well, if I divide this segment, this horizontal segment, I'm going to divide that into 4 equal parts. Divide that into 4 equal parts. Each of those would be length 2. I want a ratio that's 1 to 4. This would be 4 times bigger than this segment. So this would be 8, this would be 2, so this is 4 times larger than this one. These would be similar triangles because of our angle similarity. Those would be similar triangles. So this ratio of 2 to 8 would be the same as this ratio from here to here. Okay, so this would be 4 times this one. So I started with, this point was 6, 4. So I went over 2 from that and up 2 from that. So let's see, I started at 6, 4, which was right here. And then I went 2 to the right and then 2 up. So that would give me the point 8, 6 would be right here. And let's see, that is one of our choices. That's the second one there. That is G, 8, 6. And another way to approach this problem, if that didn't totally make sense to you, you could always just plug each one of these, plot each one of those on the number line, and see which one looks like it would be 1/4 of that whole length. Number 45, given that A times this matrix equals this matrix for some real number A, what is X plus Z? So that's what we want to know. What is X plus Z is what we want to know. Well, here is X, and here is Z. And we know that these two matrices are equal to each other. There's an equal sign between them. So that means the element, corresponding elements in each matrix must be equal. I've got this A out here that's to multiply into every element in the matrix. So if I multiply that into each element, I'd have 2A, and then 6A, 1A, and 4A. And that equals my other matrix, X, 27, Y, and Z. And those two matrices are equal to each other. I want to know what X plus Z is. Well, X is right here. X is just 2A plus Z is 4A. Those are in the same corresponding position, so plus 4A. So X plus Z then, for 2A plus 4A would give me 6A. The only thing is, if I look at all my choices there, I don't see anything that has an A in it. All of those have numbers in it. Well, if I look at my matrices again here and see that, okay, I have 6A here equals 27. So I could figure out what A equals by setting those two equal to each other. They're this corresponding elements in the matrices. So this would be, I would get 6A equals 27. Well, I notice here this was just equal to 6A, and this tells me that 6A equals 27. So X plus Z must equal 27. And I look at my choices, and that would be D.